Today we're learning about operations with radical expressions. We're in Unit 5, Lesson 5. The first thing we're going to talk about is product property of radicals. So you can multiply radical expressions, okay, as long as they are of the same root. So we've got, for example here, we've got square root of 8 times square root of 6. What we can do is we could just multiply square root of 2 times square root of 8. I forgot how to read. 2 times 8 is going to be 16, so that would be the square root of 16, or you can reduce that to 4. On this other example, we've got the third root of 3 and the third root of 9. We can multiply the 3 times 9 together to get 27. However, the third root of 27 is 3, because 3 times 3 times 3 is 27. So there's some examples of how to simplify. Let's look at the first example we have in our notes. So it says, simplify these. We have the square root of 32 times x to the 8th. Now, I'm going to kind of write this one out pretty lengthy, just so you guys can see what's going on, and maybe we can end up shortening this a bit. What I'm going to do is I'm going to take 32 and I'm going to find the prime factorization of this. So I know it's even, so I can divide both sides by 2, and I'm going to do that until I can't divide by 2 anymore. So I've got all these 2's right here, and this number right here, it's not written, but it is a 2. So what we're going to do is we're finding pairs. We're finding groups of 2. So here I have one group of 2, here's another group of 2, and then I have one left over. So I can have 2 groups of 2 coming out. So it's really going to look like this, 2 squared. And then that 2 is going to be left behind in the radical. I can take the square root of 2, but it's not going to be a nice number. So we're going to keep it in there. We're simplifying as much as possible. And then I have x to the 8th power. So that's like having 8 x's multiplied together. So I would write them all out like this. And then I'm again finding groups of 2. And I end up having 4 groups of 2. So an x to the 4th can come out. And so if I simplify this even further, I've got 2 squared, which is 4, times x to the 4th times the square root of 2. And that's how you simplify that first one. So part B, if we do the same thing, have the same idea, it's going to be a little different though, because this is now the 4th root. So we're not looking for groups of 2, we're looking for groups of 4. So I'm going to do the same thing over here. I'm going to take 16 and I'm going to break it down into my prime factors. So 2 times 8, 2 times 4, 2 times 2. So what we're going to do here is look for a group of 4, which I mean all of the ends of the roots of our factor tree are all 2's. They're all the same number and there's 4 of them. So then we've got a group of 2's can come out. And then that's all that's left of the 16. There's nothing left over inside the radical. Now, for the A's, we have 24 of them. So I could write out A, all, so on. But I'm not going to do that. I'm going to instead think in my head, how many groups of 4 can I make out of 24 of these A's? And I can make 6 groups, so A to the 6th can come out. If I'm going to do that same thing for the B's, again, I could write out all my B's, but 13 is still quite a bit to write out, and if you're doing this over and over and over again, we don't want to do that. So think of how many groups of 4 can we take out of 13 evenly. So you're going to have to think back to when we divided and we had remainders. So 13 divided by 4 is going to be 3, a full 3, but we're going to have a remainder. We're going to have 1 B left over. So that's going to have to stay inside the radical. So the simplified version of this is 2a to the 6th, b to the 3rd, and then we can't forget this little 4 right here. Okay. Now, in the last unit that we were talking about, we do have this, no, I'm just going to leave it. Yeah, I'm just going to leave it. Okay, so we just talked about the product property. We're going to talk about the quotient property. So you guys have seen this before. When we take the square root, for example, of a fraction, we divide it up. We take the square root of the numerator, divide it by the square root of the denominator. So in this case, we can do the same thing. We can go backwards. We can say, let me highlight this, square root of 27 over the square root of 3 is going to be equal to, and they didn't quite write this step, but square root 27 over 3, which if I divide that, that's where we get square root of 9, which equals 3. You can also do that when it's something other than the square root. So for example, the cubed root of x to the 6th over 8, we take the numerator over the denominator. Cubed root of x to the 6th is going to be x squared. Cubed root of 8 is going to be 2. So then if you simplify this a little more, we could write it as 1/2 x squared. It's going to be up to you guys how you would like to represent this. I'm fine either way because it means the same thing. There is one thing that I tell my students a lot, is that having a radical in the denominator is against the law. So there is something called rationalizing the denominator, where we basically undo that radical on the bottom of our fraction in order for it to be a law-abiding citizen. So for example, right here, let's say we have a square root 3 in the bottom, in the denominator. So something that gets rid of a square root is if we square that number. So for example, if I were to multiply a square root of 3 by a square root of 3, that would cancel out that square root, leaving me just with 3. However, we also have to be careful because we can't change the value of this. We can't just multiply numbers by anything because we want to. We have to make sure we multiply the top as well, because this number right here, square root 3 over square root 3, really just represents 1, and anything times 1 is itself. So it looks a little different, but it is the same value. So 2 over square root 3, when we rationalize the denominator, is going to be equal to 2 square root 3 over 3. Now it's totally fine because the radical is gone from the denominator. We can do this same thing with any root here. We can do that same thing. We have a third root of 2 on the denominator in this example. We just multiply third root of 2. We need to multiply something the same thing so it kind of cancels out there. Okay, so if we multiply third root, we're left with a 2 on the bottom. Okay, now the reason they have this squared is so we end up with 3 2's. Okay, so we end up with, here's a 2 here, and then we'd have a 2 and a 2. So when we take that third root of 2 times 2 times 2, it would end up just being 2 on the bottom. So we'll have to make sure we create that number that's on the outside here. So we have 2 times 2 squared is that 2 to the third, that when I take that third root, it just cancels out. So there's a little bit of a difference here on a root that is not just the square root. So be looking for that. We'll do some examples here on example 2. So this one says simplify x to the 6th over y to the 7th. So I've got x to the 6th, and I'm going to split this up over square root of y to the 7th. If I simplify this as much as possible, I've got the top is just going to reduce down to, or simplify down to, x to the 3rd, because this right here is the square root. So 6 divided by 2 is going to be 3. If I did that same thing for the denominator, I would have y to the 3rd, but I have a y left over. Luckily, though, it is just a square root of y. So in order to rationalize the denominator, I could multiply both top and bottom by just square root y. So then I've got an x to the third times square root y on the top. These two right here turn into just y, which y to the third times y is going to be y to the fourth on the bottom. Okay. Part B is a bit different. We now have the fourth root here. So if I split it up, I've got the fourth root of 6 on my numerator. I've got the fourth root of 5x as my denominator. Now, I can't really simplify anything here because there is no beautiful fourth root of 6 or a fourth root of 5x. So what I need to do is focus on getting the denominator rationalized. So what I'm going to do is I'm going to create that. I'm going to multiply top and bottom times the fourth root of 5x, and not just 5x, but 5x to the third. Because again, I'm trying to create something that eliminates that entire root on the bottom. Because if I have 5x to the third here and 5x here, that's my 5x to the fourth, where if I did take that fourth root, that would cancel out on the bottom on my denominator. So since I did that on the bottom, I need to do that to the top. So times fourth root of 5x to the third. So then the top is going to look like this, and I should probably distribute that, and I will here in a second. So 6 times, this will be 5 to the third times x to the third over, now this is going to cancel, leaving me just with 5x on the bottom. So then if I keep going and simplify that even further, 5 to the third, so 5 times 5 times 5 is 125. And if I multiply that by 6, I should get 750. So my numerator is fourth root of 750x to the third over 5x. And then that is as simplified as we can get. There's nothing else we can do. So I'm going to put a box around this and call it good. All right, so we're going to continue with example 3 and then on to example 4, which is now actually multiplying, adding, and subtracting radicals, and then example 5 is also multiplying more radicals. So when we talk about simplifying when we talk about simplifying a radical expression, sometimes we're a little confused on what that means. So here is an example. A radical expression is in simplified form when the following conditions are met. So if you have all of these conditions met, you're done simplifying. So the index n is as small as possible. The radicand contains no factors other than 1 that are nth powers of an integer or polynomial. The radicand contains no fractions, and then no radicals appear in the denominator. So this might be a little confusing, but let's go through and look at example 3 here. So we've got simplify, and then we've got 5, yeah, all that. So what I'm going to do first is, since these are both roots 3, square root, or not square root, third roots, I can multiply the numbers inside the radical. I can also multiply the 5 and the 3 on the outside. So what I can do here is I can say 5 times 3 on the outside, and then on the inside, I'm going to take this entire 12 ab to the negative 12 ab to the fourth, multiply it by 18 a squared b squared. So this is going to be 15 times the square root, negative 12 times 18, and I don't know if I want to multiply that out right now because I'm going to end up breaking it down anyway. So what I'm going to do, okay, let's come back to that. So we'll have a to the third, b to the eighth. I think maybe I will multiply this out. And then we'll break it down from there. Because you could, okay, let Mrs. White kind of talk her way through this here. So we could break this up. We could do what we were doing before. 2 times 3, 18, 2 times 9, 3 times 3. However, the thing is, we would be multiplying these two things together. So now we can find groups of 3. This is 3, don't forget that. We can find groups of 3 as a combination of both of these. So see here, we've got 3 3s, and we've also got 3 2s. And I think this might be the easiest way to do it. I was thinking of multiplying the 12 and the 18 together, but that just might get away from us. Something to point out, though, it is a negative. So one of these factors should have a negative with it. So let's have a negative 2 to the third and a 3 to the third on the inside. Okay. So then what I'm going to do is I'm going to take the third root of everything. So I've still got this 15. The third root of negative 2 to the third is just going to end up being negative 2. The third root of 3 to the third is just 3. The third root of a to the third is just a. The third root of b to the eighth. How many groups of 3 do I have in 8? So think about, we've got 3, 6, and then if we had another group, it'd be up to 9. So we can only come up with 2 groups. And then we have some left over. So we've taken all of these out. We've reduced this. We've reduced this. We have 2 b's, so b squared, left inside the radical. So now we can simplify even further. We could do 15 times negative 2, which is negative 30, times 3, which is negative 90. A b squared, square root of b squared. All right, so these last 2 examples, we are actually going to do the operations with radicals here. Example 4, we're going to subtract, and then example 5, we're going to end up multiplying. So the first thing we want to do is we can't subtract radicals unless they are exactly the same. So square root of 98, we can't do square root of 98 minus 32. We can't, it's like saying x and y, and we can't do x minus 2y. We don't know what that would be. So what we need to do is we need to simplify each radical first, and then see if anything matches up, and then simplify even further. So what I'm going to do is I'm going to take this 98, and I'm going to break it up like I have been. So 98 cut in half is going to be, I just, brain for 49, thank you. And then we've got 7 and 7. So we've got a pair of 7s here, and it is a square root, so I could take my 7 out, and I'm left with square root 2. And then I've got this 2 on the outside here. I'm going to break up 32. 2 times 16, 2 times 8. Some of you guys might be able to jump to exactly what it is. I'm just showing you my method of doing it. You guys can probably jump right here is a perfect square. So we could say, oh, well, 4 is going to come out because square root of 16 is 4. So we're going to have times 4 square root, and then we've got a 2 left over. So we've got 7 square root 2 minus, this will become 8 square root 2. Now, see how these are exactly the same. This is just like saying 7x minus 8x, which is just negative x. So we can do that same thing here and say this is equal to negative square root 2. Example 5 is a bit different because this is multiplying 2 binomials. So we're going to have to FOIL. You guys remember that? Your favorite. That means favorite operational instrument of learning. I'm just kidding. Okay, so the first, so 12 times square root 6. You can multiply radicals. We just can't add or subtract them if they're not the same. Then we've got negative 6 times 4 is 24 times square root 3. Multiply these, so 15 times square root 4. And yes, I can simplify that. I'll do this in the next step. Negative 6 times 5 is going to be negative 30. And then we've got square root 2. So from here, I'm going to see what else I can simplify. And if you notice, square root of 4, we might not have even needed to write that, but this piece is going to be 5 times, or 15 times 2, because square root of 4 is 2. This we can't quite simplify by itself. This we can't simplify by itself. That one we can't simplify. So from here, there's a lot of pieces that we can't simplify any further. So we're going to have to write this out kind of as a long statement expression here. So 12 square root 6 minus 24 square root 3 plus 30 minus 30, okay, fix that, 30 square root 2. If there was anything else that we could simplify here, we'd probably be able to combine things, but since none of these radicals are the same, your answer will be this long expression here. I know that it might look weird, but it is as simplified as we can get.